हेलो फ्रेंड्स, गुड मॉर्निंग दोस्तों। कल के बाद आज फिर एज वी आर डिस्कसिंग द एनवायरमेंटल इंजीनियरिंग पार्ट, सो वी आर कंटिन्यू विथ आवर डिस्कशन। क्या है कि कल हम लोग क्या डिस्कस किए थे? कल हम लोग डिस्कस किए थे वाटर डिमांड। आई एम जस्ट गोइंग थ्रू दैट प्रोसेस वंस अगेन कि व्हेन वी आर स्टार्टेड डिस्कसिंग द एनवायरमेंटल इंजीनियरिंग, मैंने बोला था कि व्हाट इज द ऑब्जेक्ट ऑफ एनवायरमेंटल इंजीनियरिंग, व्हाट आर द पार्ट when we had started discussing the environmental engineering, मैंने बोला था कि what is the object of environmental engineering, what are the part, and also आप लोगों के साथ ये था कि पहला जो चैप्टर है इसका दो सेगमेंट है, एक है वाटर डिमांड और सेकंड है पॉपुलेशन फोरकास्टिंग। Yesterday's class we have discussed about this water demand segment, and today we're going to discuss about the population forecasting. Now before go into the details, my thing, don't forget आप भूले नहीं कि Unacademy learning app जो है उसको इंस्टॉल करना। You can go to this Play Store, or if you're having iPhone then उसका जो है eventually you can search there Unacademy learning app. You can see the logo, then you can install that particular app in your mobile, and then you can go for this as you are going for GATE and EAC. Going for GATE and EAC, that particular places there, lot many courses links are provided, and then you can go for Unacademy Plus, where you will get the topmost educators of Unacademy, and then you can go for this subscription details, get subscription. Now, during getting the subscription, don't forget to use my code. It SEN10. It's SEN10. You'll get a discount over there. So, and then after applying that code, you can go for this proceed payment. So, don't forget to use my code. And once again, there is a combat challenge called as Unacademy Combat. It's there. It is nothing but examination, but you need to compete with the best to know your standings over there. आप किधर हैं ये सारे कुछ समझने के लिए, that is the thing, compete with the best. And then after that questions, all the questions will be set up by the topmost educators. Detailed video solution will be provided by top educators. You can see what will be the solutions for those questions, and then obviously lucrative prizes are there. If you are getting the first position, you will get Apple MacBook Air, Apple iPad Mini. In if you do second position, Apple AirPods, and for top 100 rankers, we is going to get the 100,000 rupees Amazon vouchers. So in brief, it's going to happen on 16th. Indian largest today itself, India 6 p.m. So it's Indian largest fortnightly competition for GATE, challenging GATE questions created by the best educators, super fast and fun with real-time rankings, compare with the best, detailed video solution by top educators. Enrollment is completely free. Hurry up, its still time is there, and you can go for compete, crack and conquer. Great news is from 28th December 11:15 a.m. there will be a evolve for GATE 2020 batches, English and Hindi both. Quickly you can join those batches if you are aspirant for GATE 2022. And once again I am telling you, don't forget to use, when you are joining that batch also, don't forget to use this code SEN10 SEN10. It's my code. Please go with that code when you are joining this particular course. Now, as we have gone for the yesterday's class in brief, and we have seen all those water demand segment. So today, what we need to go for? We need to go for population forecasting process. तो भैया जब आज हम लोग क्लास 2 में पॉपुलेशन फोरकास्टिंग देखेंगे, व्हाट इज पॉपुलेशन फोरकास्टिंग, what is the thing, what we need to understand regarding population forecasting. Now when we are concerned about the population forecasting part, तो पॉपुलेशन फोरकास्टिंग का कहानी क्या है ये डेफिनेशन लिखा हुआ है, लेकिन that will come later. पहले समझने की कोशिश कीजिए है क्या. कुछ देर के लिए आपको ज्योतिष बनना है. आप अभी सिविल इंजीनियर नहीं हो. क्या करना है? कोई भी एरिया का पॉपुलेशन, जनसंख्या को फोरकास्ट करना है, उसका भविष्य में क्या वैल्यू होगा वो देखना है. पहला क्वेश्चन है कि क्यों, और दूसरा क्वेश्चन है कैसे. फर्स्ट क्वेश्चन इज क्यों. क्यों करना है आपको पॉपुलेशन फोरकास्ट? क्यों करना है आपको? क्यों देखना है आपको पॉपुलेशन फोरकास्टिंग? व्हाई? द रीजन इज when you are going for this population, when you are going to for the designing of any kind of system, there are certain design periods assigned. Look at this slide. For dams 50 years, intakes 30 years, conveying pipe 30 years, pumps 15 years, treatment unit except rapids and filter 30 years, rapids and filter 15 years, distribution system 30 years. So each and everything is having certain amount of design periods, right? Now when each and everything is having certain amount of design periods, that means you are designing something. आप कुछ चीज को डिजाइन कर रहे हो. सपोज आप 2020 में आप कुछ चीज को डिजाइन कर रहे हो, तो दैट मीन्स इट शुड व्हाट, इट शुड सर्विस यू मोर देन 2070. यस और नो? नाउ सपोज डैम्स यू आर डिजाइनिंग 2020 में. डिजाइन पीरियड मतलब जब जब उस टाइम पे ये क्या है डिजाइन पीरियड? तो यूटिलिटी पीरियड और यूजफुल लाइफ पीरियड, जहां पे उसका प्रोबेबिलिटी ऑफ फेलियर इज कांस्टेंट विद टाइम. ओके. नाउ when the probability of failure is constant with time, then you are going for this design period. Now when this design period is there, what is next? So ये अगर 50 साल होता है तो उससे ज्यादा भी, उससे ज्यादा और कम, मतलब सोचिए कि यहाँ पे 10 साल है और यहाँ पे आपका इधर 10 साल है. If you see now, if it is 50 years that process, so अगर ये है तो ये अगर 50 साल है आपका, तो यहाँ पे कुछ टाइम इन्वॉल्व है और इधर भी कुछ टाइम इन्वॉल्व है. तो क्या होता है? तो मतलब लगभग लगभग सोच लीजिए कि सब कुछ मिला के 70-80 साल का कहानी है. मतलब 2020 में अगर कुछ कर रहे हो तो 2100 तक आपको ये सर्विस देना चाहिए. Now when you are going to design a dam, your actually design demand is Qmax daily. देखिए, तो what is Qmax daily? कल हम लोग डिस्कस किए हैं. Qmax daily is nothing but 1.8 into Q average. Now what is Q average? It's population into per capita water demand. So population into per capita water demand. If अगर मैं सोच भी लेता हूं कि per capita water demand is fixed, then we need to go for this population value. How? Population value के मतलब, तो population P 2020 will it be equal to P 2100 or will it be equal P 2030? तो अगर आप आज के पॉपुलेशन के मुताबिक इसको डिजाइन करोगे, then obviously as your population value is going to get increased, कुछ साल बाद ये डिजाइन आपको फेलियर हो जाएगा, क्योंकि पॉपुलेशन वैल्यू आप उस हिसाब से नहीं लिए हैं. तो क्या चाहिए? That means when you are sitting today, you need to design your system on the viewing of the 2100 process. आज के डेट में आज का जो पॉपुलेशन है, वो पॉपुलेशन आपके पास कोई भी एक सेंसस होगा, आपको मिल जाएगा. लेकिन व्हाट विल बी द पॉपुलेशन आफ्टर 70 years, 60 years, 50 years, 30 years? That is the process. So finding out the population of a particular catchment or a community is called as this population forecasting methods. It is the method of forecasting the tentative population of future decades on the basis of past population data. It is the method of forecasting the tentative population of future decades on the basis of past population data. It's called as trend analysis of particular catchment or community. So on the basis of past data, उसका ट्रेंड कैसा है, उसका वो कैसा सिटी है, उसका क्या है, वो सारे चीज को समझने के लिए और पास्ट डेटा के ऊपर स्टैटिस्टिकल एनालिसिस करते हुए भविष्य का पॉपुलेशन बताना, ये जो है इसको कहते हैं पॉपुलेशन फोरकास्टिंग मेथड. Now before going to the different methods of population forecasting, what we need to understand is a graph or a curve. That graph or curve is actually representing a plot of population versus time. How the in what position, in what time, what is happening with the population. This graph or plot is generally formed on the basis of bacterial population data. But in our case, we will assume that the human population will also following that bacterial population process. Okay. The graph or plot is called as S-curve or sigmoid curve or logistic curve. Let me explain the graph or plot first, then you can understand it properly. So, hope you are able to view this plot. So, first of all, so there are, this is P versus T plot. Population in y-axis and time in x-axis. P versus T plot. Now, first there is this green dotted line. This green dotted line is representing the saturation population. Saturation population means the maximum population that can be there in a particular catchment area. Saturation population. The maximum population that can be there for a particular catchment area. Now, come to this plot. पहले सोचिए कि आप, मैं बैक्टीरियल पॉपुलेशन के हिसाब से आपको एक्सप्लेन कर रहा हूं. सोचिए कि आप एक प्लेट लिए हैं और आप एक प्लेट में दो माइक्रो ऑर्गेनिज्म बैक्टीरिया को रखे हैं. You are providing food, water, oxygen, or if it is required, whatever it is required, you are providing to that system. For first few time, कुछ देर के लिए, कुछ time के लिए, those bacterial mass, what they will do, they will try to judge, because that's a new area, that's a new position, that's a new place to them. They will start judging the place whether that place is suitable for their future generation or not. During this judgmental period, their number will not increase, or if it is increased, that will be negligible, only their body mass will increase. In that particular period, AB segment is defined. Segment AB is called as lag phase, where population is constant. See here, it's called as lag phase, where population is constant. If the population is constant, quite obviously your dB dt is equals to 0. So यहाँ पे जो टाइम कंज्यूम हो रहा है, ऑब्वियसली देयर विल बी सम y axis value, sorry, x axis value, but y axis value is almost equals to 0, and a point here, pa, अगर आप देखोगे कि point a में जो population है, that is pa, where pa is the population at time t equals to 0. pa is the population at time t equals to 0. तो अब a से b तक पहुंच गया कहानी, और b से b पे आने के बाद क्या हो रहा है, when it is reaching b, then what is happening, then when it is reaching b, it is getting that okay, now it's the time for our number growing the number. Why? Because at point b they are getting that confidence, okay, this place is suitable for our future generation. So B to the rest part is called as log phase. B beyond B, everything is called as log phase. Beyond B, everything is called as log phase. Now, initially, when they are getting confident that segment DC, they are actually what they are doing, they will grow their numbers exponentially. They will grow their numbers exponentially. Today if it's 2, tomorrow it's 4, then 8, then 16, then 32, like this they will, or whatever it may be the power, they will grow their number exponentially, where dp dt is equals to a exponential and exponential function, and it will go up to point c. The segment BC is showing you exponential growth phase. Segment BC is showing you exponential growth phase. Is it clear? Now, coming to point C, after that, after reaching the point C, they will realize. So after reaching point C, what will happen? It's in at point B, it was a new city, but when they are reaching point C, it's already a new city, means new place to them. Already it's an old place to them. When they are reaching point C, what will happen? That after point C, what they will do, they will realize that if they keep on increasing their number, if they keep on increasing their number at this rate, so after certain point of time, they will have a problem with food and resources. Survival of the fittest question will arise. After point C, if they will realize if they are keep on increasing the number at this rate, then they will have survival of the fittest question. They will have certain limitations in the food and everything resources. What they will do? They will obviously they will increase the number. They will increase the number, but they will check the rate. Now they will increase the number at a constant rate up to point D. Now constant rate means for CD, dp dt is constant. For CD, dp dt is constant. Now if dp dt is constant, so here it is told that dp dt is constant. When the this m, or this is the tangent part, is getting constant, if dpdc is constant, so then obviously if you put it, it will be a straight line, so it is nothing but linear growth phase. Linear growth phase, it is nothing but linear growth phase. So that is showing by segment cd. Check it out. Linear growth phase showing by segment cd. Now After point D, what will happen as that the place is already exploded and quite old. So new microorganism will come, but along with that, some old microorganism will die also. So there will be growth phase, but the the population will have a decreased growth phase because it is slowly, of beyond point D, it is slowly approaching towards the saturation. So beyond point D, you can say it is slowly approaching towards saturation, slowly approaching towards saturation beyond point D. So if you see the graph, you will see it is the shape of the graph is like a S of X alphabet, English alphabet. That's why this graph or plot is called as S curve or sigmoid curve or logistic curve. That's why this graph or plot is called as S curve, is also called as sigmoid curve and logistic curve. And by virtue that the C point is generally called as point of inflection. The point C is called as point of inflection. The point C is called as point of inflection. So quickly I am revisiting the plot. It's population versus time plot. First segment AB is called as the lag phase where P is constant, and if P is constant, quite obviously dPdt will be 0. So you can say here that P at point A, it's almost equal to population at point B. You can say that population at point A is almost equals to population at point B. Okay, almost equals to means if the increase is there, that will be also negligible. बी के बाद पूरा चीज को कहते हैं लॉग फेज, और पहला सेगमेंट जो है बीसी, बीसी सेगमेंट में क्या हो रहे हैं, जब उनको कॉन्फिडेंस मिल रहा है कि भैया यही प्लेस है हमारे पॉपुलेशन ग्रोथ के लिए, देन व्हाट विल हैपन, देयर विल बी अ एक्सपोनेंशियल ग्रोथ रेट. dpdt will be an exponential function, they will grow exponentially. At point C, at point C, they will get realized. So this is actually the exponential segment BC. Then at point C, this is a straight line, linear growth phase, straight line segment. And this is decreasing growth phase. So at point C, they will realize if they keep on increasing their number at this rate, obviously very quickly they will see this survival of the fittest wala part. So they will check their growth rate. What will happen? They will go for a linear growth phase. They will grow for what to say? They will go for a constant growth rate. And if as it is dPdt will be constant and linear growth phase will be observed. After D, there will be a decrease in growth phase. Beyond point D, there will be decrease in growth phase. And beyond point D means the portion is slowly approaching towards saturation. Beyond point D means the portion is slowly approaching towards saturation. Okay. Now we need to go for different population forecasting method. We need to go for different population forecasting method. First method is arithmetic mean method. Don't go, right now please concentrate on the term arithmetic mean method. Don't go for others whatever is written in the slide. Just go for the term arithmetic mean method. Now when you are considering this arithmetic mean method, The first thing is it is applicable. This is applicable for old and settled cities. This is applicable for old and settled cities. Now coming to, and here DPDT is constant is assumed. So when it is applicable, arithmetic mean method, it is applicable. These are the assumptions that it is applicable for old and settled cities, where dp/dt is equals to constant. So if dp/dt is equals to constant, so which segment of this curve the arithmetic mean method is applicable? That is for the CD segment, because here only dp/dt is equals to constant for linear growth phase. So and representing the CD segment of this curve. See, it is written here. Representing the CD segment of this curve. Now see, statistically, that it is represented by an equation which is Pn is equals to P naught plus Nx bar. Statistical approach है, उसका representation एक equation is Pn is equals to P naught plus Nx bar, where Pn is the population after nth decade, where Pn is the population after nth decade. Population after nth decade. My decade means 10 years. And P naught is the population of last known decade. This is very, very important. Don't get confused. Normally, when you are going for suffix 0 or not, we generally write it, take it as time t equals to 0. No. Here, population of last known decade is represented by this term P naught. Population of last known decade is represented by this P naught. N is the number of decade. N is number of decade. So once again, the equation is showing as Pn is equals to P naught plus Nx bar, जहां पे आपका arithmetic mean method का दो चीज क्या है? It is applicable for old and settled cities, and dp/dt. dp/dt is constant, applicable for old and settled cities, and dp/dt rate of change of population with time is constant. So in which position it is applicable for the curve? It's representing the CD segment of the curve, representing the CD segment of the curve. And statistically it is expressed by Pn is equals to P naught plus Nx bar. Statistically it is expressed by the equation Pn is equals to P naught plus Nx bar, where x bar is the average increase in population per decade. Average increase in population per decade. And Pn is the population after nth decade, and P naught, be careful about P naught. You need to be careful about P naught. It is a population of last known decade. Population of last known decade. And N is the number of decade. And N is the number of decade. So if it is represented graphically, there is a straight line segment because it is considering the CD segment, which is the straight line segment. So dp/dt is constant. So for a given dt, dp1 will be almost equals to dp2. Sorry. Now, I've done here one problem statement to show you that how we should proceed for this popular arithmetic mean method process. The population of 5 decades is provided, and find out the population after 1, 2, 3 decades. The population of 5 decades is provided, and find out the population after 1, 2, 3 decades. What are the 5 decades provided? 1930, 25,000, 1940, 28,000, 1950, 34,000, 1960 42,000, 1970 47,000. These are the data provided for this question. How to solve? What they're asking? They're asking the population after 1, 2, 3 decades. See, first what we'll do, we'll take the population of 1930 25,000, 40 28,000, 50 34,000, 60 42,000, 70 47,000. We have written. Now we need to calculate the x values. What will be the x value? X1, which is what? X1 is equals to actually that difference in population, final population and the initial population. So here X1 is equals to P2 minus P1, 28,000 minus 25,000. 28,000 minus 25,000, that's written as 3,000. What is X2 then? X2 is 34,000 minus 28,000. 34,000 minus 28,000 is 6,000. That is X2. What is X3? 42,000 minus 34,000. 42,000 minus 34,000, it's 8,000, that is X3. 42,000 minus 34,000, that is 8,000, which is X3. And X4 is 47,000. 47,000 minus 42,000, because P2 minus P1. Difference between population final minus initial. That is X4. So you are getting X1, X2, X3, X4. You need to calculate the X bar. X bar is equals to summation of X all X by 4. Summation of all summation of X by 4. Which is, if you add, it will be 3,000 plus 6,000, 9,000 plus 5,000, 14,000 plus 8,000, 22,000. 22,000 divided by 4, you are getting what? 5,500. Okay. Now, if n is equal to 1, they are asking for 1, 2, 3 digits. Suppose n is equals to 1. If n is equals to 1, then what we will see? So n1 means Pn. Formula is what? What is the formula? If you remember that Pn is equals to P naught plus nx bar. Pn is equals to P naught plus nx bar is the formulation part. So your P1 means n equals to 1. Now for which decade you are getting the value? One decade means from the known data. Known year is how, which one? Known year is 1970. Known year is 1970. From that one decade means 10 years, that is 1980, which is equals to P naught. It is P naught. P naught is what? The population of last known decade. Last known is 47,000. Once again, this is your P naught. Don't get confused regarding this P naught. This is your P naught. So P naught is population of last known decade 47,000 plus n is 1 plus x bar is 5,500, is 52,500. P2, its population for 1990, from 1970 to 2 decades means 20 years. See, when you are going for statistical process, then you have to always here for you have to always take the given data. Don't do that P22 is P 1990 means you are starting from P 1980. In this case, you will get same answer because it's arithmetic mean method, and as it is arithmetic mean method, but DPDT is constant, to be assumed to be constant. But always you will not get that. So it will we will start with from P naught, the population of last known decade. आपको P naught से चालू करना है, मतलब जो population of last known decade है, जितना डेटा दिया हुआ है, क्योंकि 1980 का जो डेटा है, ये डेटा आपका गिवन डेटा नहीं है, ये एस्टिमेटेड डेटा है. और एनालिसिस में आपको अगर आगे बढ़ना है तो गिवन डेटा के साथ आगे बढ़ना है, एस्टिमेटेड डेटा के साथ नहीं. So 47,000 plus 2 into 5,500, which will be 58,000. That is P2. Okay. Similar fashion, if you go for P3, Here, if you go for this P3, what will be the thing? P3 will be P naught is 47,000 plus N is 3 into 5,500. The answer will be 63,500. That will be your P3 value. Okay. Now, we are going for the second method. We are going for the second method, that is geometric increase method. Second method, that is geometric increase method. Like the arithmetic method which is applicable, arithmetic method जो हमने पहले देखा, this is applicable for old and settled cities, whereas the geometric method, it is applicable for young and rapidly growing cities. It is applicable for young and rapidly growing cities. Here it is written that assume is exponential growth rate is assumed. Exponential growth rate is assumed. So as exponential growth rate is assumed, so obviously if you look at the curve here, which segment is getting this exponential growth phase? PC segment. PC segment. And also see, here also it is starting. Here also if you see in the curve, it is starting. Just AB means just after the lag phase. So young, very young and growing cities. Here it is old, bit old and settled already. So from the curve itself, you can understand that what the methods will going to use. Okay. अभी इधर अगर आप देखोगे तो geometric method में exponential growth phase is assumed में here if eventually it will be like dp will be an exponential function. After dp obviously exponential function ही होंगे. Now it is representing the BC segment, obviously representing the BC segment, and for a given dt, it is dt1, if it is dt2, if it is dt3, and if it is dp1, dp2, dp3. So obviously for a given say given dt क्या होना है, dp1 will be less than dp2 will be less than dp3. That is the exponential function process, and dp dt is directly proportional to the population at time, क्योंकि जितना है वही पॉपुलेशन टाइम टी के ऊपर डिपेंड करेगा. जितना है, जितना फाइनली जितना है, मतलब जो है, सोचिए कि आज है 2, कल है 8, परसों है 16. तो ये जो 16 जो डीपीडीटी है 8 से 16 के बीच, वो किसके ऊपर डिपेंड करेगा? मतलब डायरेक्टली प्रोपोर्शनल विद दैट कितना वैल्यू है. अगर ये 8 से 16 ना होके 4 से 16 होता या 10 से 16 होता तो डीपीडीटी वैल्यू विल चेंज. So DPDT, or if it is this initial one is fixed, then how much is the final one? That will define the DPDT value, that population after time t. Is that clear? So DPDT value is directly proportional to the population after time t. Now, as there is a definition, as the DPDT value is directly proportional to PT, then DPDT is equals to KPT. K is the proportionality constant. So dp by pt, I'm just going for cross multiplication. So dp dt is directly proportional to pt that we have discussed. So dp dt is equals to kpt that we are now discussing, where k is the proportionality constant. And dp by pt is equals to k into dt. dp by pt is equals to k into dt. And if we take log, if we integrate the thing, what we are going to get, it will get ln pt, because dt by pt is ln pt from p1 to p2, from initial population to final population, is equals to k dt, k into t, t1 to t2, k into t, t1 to t2. So ln here p2 by p1, ln p2 by p1 is equals to k t2 minus t1. ln p2 by p1, upper limit minus lower limit, equals to k t2 minus t1. So eventually p2 by p1 is equals to e to the power k t2 minus t1. So from here P2 will be equals to, so P2 by P1 equals to e to the power k T2 by minus T1. So here P2 is equals to P1 cross multiplication e to the power k T2 minus T1. It is very important to know what it is, that it is mathematical approach. Be careful about this. It is not the statistical approach. Just mathematical approach. And K is actually called as the growth rate percentage per year. K is called as the growth rate percentage per year. It is a mathematical approach, and K is called as the growth rate percentage per year. Growth rate percentage per year. Okay. So I am repeating once again, dPdt is directly proportional to Pt, and dPdt is equals to K into Pt. dPdt is equals to K into Pt, and dP by Pt is equals to K dt, where if you integrate ln Pt is by it from P1 to P2 will be K into T, T1 to T2. That means at time T1 population is P1, at time T2 population is P2. So eventually it will be ln P2 by P1 is equals to K into T2 minus T1, where P2 by P1 is equals to e to the power k T2 minus T1, where P2 is equals to P1 e to the power k T2 minus T1. It's the mathematical approach where k is the growth rate percentage per year. Growth rate percentage per year. Okay. Statistical approach. Just ignore the second segment. Just ignore this segment right now. Statistical approach is PN, population after n decade, is equals to P naught, population of last known decade, into 1 plus R by 100 whole to the power n. P naught into 1 plus R by 100 whole to the power n, where R is equals to growth rate percentage per decade, where R is equals to growth rate percentage per decade. R is equals to growth rate percentage per decade, and where R is equals to nth root, where R is the geometric mean of. Sorry for the disruption. Sorry for the disruption. So here, the statistical approach is defining Pn is equals to P naught into 1 plus R by 100 whole to the power n, where R is the growth rate percentage per decade, where R is the growth rate percentage per decade, and R is equals to the geometric R is nothing but the geometric mean of different R values. PR is nth root R1 into R2 R3 Rn. So now we are going for the same problem as we have discussed. We are going for the same problem as we have discussed in the arithmetic method. Why we are going for the same problem data, that we will discuss later also. So 1930, 25,000 given the population data of 5 decades, 1930, 1940, 1950, 1960, and 1970. Respective populations are 25,000, 28,000, 34,000, 42,000, 47,000. So, and we know how to calculate the x values. We know how to calculate the x values: 3,000, 6,000, 8,000, 5,000. We know how to calculate the x values. Okay. So we have seen that in previous thing, that how to calculate this, x values we have gone through. Now here, Now we need to calculate the R values. Now what is R values? So here see, for this case, R1 is actually equals to X1 by P1 into 100. If you go with this, X1 is 3000, X1 is 3000, P1 is 25,000. So it's nothing but 3000 by 25,000 into 100. That is XR1. And the value is provided as 12. The value is as 12. On similar fashion, you need to go for calculating the you need to go for calculating the R2 values. You have to calculate the R2 value. Now, what will be R2 value? On similar fashion, same process. So just you need to think that what is happening with the R values. Same thing. So where R2 will be equal to X2 by P2, X2 by P2 into 100. So what will be that X2? It's 6,000, 6,000 by 28,000 into 100, and the value will be 21.4 mentioned here. Value will be 21.4. On similar fashion, if you go for R3, it will be X3 by P3 into 100, which is nothing but 8,000 by 34,000 into 100. R3 is 8,000 by 34,000 into 100, and the value will be 23.53, and the value will be 23.53. Same. If we are going for X4, sorry, not X4. If we are going for R4, if you are going for R4, then what you are going to get? R4 will be equals to X4 by P4 into 100. So it is nothing but 5,000 by 42,000 into 100. Value is 11.9. So all these R values are listed here. R1, R2, R3, R4. All these R values are listed here. Now what we need to do, you need to go for uh, this. You need to go for this R. R means the geometric average, fourth root of 12, R1, R2, R3, R4. R1, R2, R3, R4. You are going to get the value as 16.38. You are getting the value as 16.38. Okay. Now what you need to do? You need to calculate. You need to calculate the P1, P2, and P3. Here P1 and P2 is calculated. P1 will be equals to what? P naught. What is the formula? What is the formula? Formula is nothing but uh, P Pn. Formula is Pn is equal to P naught into 1 plus R by 100 whole to the power n. That is the formula, right? So it's P naught 47,000. Once again, you know what is the population of last known decade. 1 plus R is 16.38 by 100 whole to the power n, because for P1 n equals to 1. Answer is 54.690, 54 not point, 54,696, 54,696. On similar fashion, there will be P2. P2 will be equals to P9090, which is 47,000 into 1 plus 16.38 by 100 square is 63.658. Or you can go for P3, which is population for 2090 from 1970 is 47,000 into 1 plus 16.38 R by 100 whole cube. There will be a value for P3. 1 plus 16.38 R by 100 whole cube. It's 74,085. Okay, 74,085 will be the value. Now the point is, so P1, P2, P3 value you are getting. Now my question is, you can ask that, sir, why we are solving the same problem once again, what we have solved in arithmetic method and geometric method. Same problem but different methods. Now from arithmetic method, the values of what? P1, P2 is how much? 52,500, 58,000. I have solved for P3 also. You will see it will be 63,500. And here P1, P2 का value कितना आ रहा है? 54,696, almost 700. 63,658 and 74,085. So on the basis of same data ले रहे हैं आप. On the basis of same data, you are taking the same data for arithmetic method and geometric method. Just आपका जो method है वो अलग हो रहा है. You are taking the same method. Only what you are doing, you are taking different uh, what to say, you are taking different methods. You are taking the same data, different methods. Your population forecasted, जो value आ रहा है आपका population forecasted P1, P2, P3 values are different. You are taking same data, same past data, लेकिन as you are, if you are changing the method, what you are getting different values. You are getting different estimated values. Whereas the arithmetic method is giving you much more lowered value than the geometric method. So if अगर आपके पास ऐसा कोई सिटी है, जैसे सोच लीजिए कि मुंबई, कोलकाता, दिल्ली, दे आर ओल्ड सिटीज, बट ऐसा नहीं है कि वहां पे सेटल्स लीनियर ग्रोथ फेज आप अप्लाई कर सकते हो. सो इस तरीके का कोई सिटी हो जो है ओल्ड सिटीज, बट देयर ग्रोथ रेट कैन नॉट बी डिफाइंड इन डायरेक्टली. When you are confused means it is old or settled cities but showing some abrupt rate of population change, or it is a young cities but it is not showing a proper exponential population change. In this confusion states, what will happen, you need to go for another method, that is the third method of population forecasting. That is the third method of population forecasting, which is called as incremental increase method, which is called as incremental increase method. We'll go for incremental increase method. What is incremental increase method? Incremental increase method में जब confused growth rate is there, confused growth rate, you can have that old and settled cities, then something will be there. You can have this new cities, new and young and new cities or growing cities, that can be another thing. Geometric, the exponential growth rate, that can be another thing. Linear growth rate, that can be another thing. But if it is a confused state of growth, then you need to go for incremental increase method, where Pn will be equals to P naught plus nx bar plus n into n plus 1 by 2 into y bar. Pn is equals to P naught plus nx bar plus n into n plus 1 by 2 into y bar. It's the extension of arithmetic mean method, where Pn is known to us population after nth decade, P naught is known to us population of last known decade, N is the number of decade, X bar is the average increase in population per decade, and the new term is Y bar, where Y bar is average of incremental values per decade. Average of incremental values per decade. Now, we are going to solve the same question once again. We are going to solve the same question once again. What is the same question? The population of 5 decades are given: 1930, 1940, 1950, 1960, 1970. Population of 5 decades are given: 1930, 1940, 1950, 1960, 1970. 25,000, 28,000, 34,000, 42,000, 47,000. This population of 5 decades are given. So what we need to find out? P1, P2, and if it possible P3 also. Okay, fair enough. Now see, first we need to find out the X values. So what is the process to find out the X values? That we know already. So X is nothing but P2 minus P1, and estimated here 3,000, 6,000, 8,000, 5,000, everything is estimated. Well, so it is X1, this one is X2, this one is X3, and this one is X4. Fair enough. Now you need to go for Y values. Y1 is equals to X2 minus X1. Y1 is actually, Y value is actually the difference between the X values. X2 minus X1, final X values minus initial X values. That is Y2, which is equals to X3 minus X2. So that's why 6,000 minus 3,000 is 3,000. 8,000 minus 6,000 is 2,000. Y2 is equals to X3 minus X2. And here is Y3, that is equals to X4 minus X3. Y3, that is equals to X4 minus X3. It's 5,000 minus 8,000 minus 3,000. So Y bar is equals to summation of Y by 3. Y bar is equals to summation of Y by 3. It is 2,000, because 3,000 minus 3,000 will get cancelled. 2,000 by 3 is 666.67. Now P1 is equals to, what is the formula? P naught plus nx bar plus n into n plus 1 by 2 into y bar. P naught plus nx bar plus n into n plus 1 by 2 into y bar. Correct. So P1 is equals to 47,000 plus P naught n into x bar, n into x bar plus n into n plus 1 by 2 into y bar. If you calculate, you will get 53,167. P2 is equals to 47,000 plus n2 into x bar 5,500 plus 2 into 2 plus 1 by 2 into 666.67 into 60,000. So eventually, these are the P1, P2 values, correct? So eventually what you will get, once again, why we are going for the same question. So let's take the value P1. P1 for incremental increase method, you are getting the value as 53,167. P1, you are getting that value as 53,167. And uh, which is lesser than the value for P1, which what you are getting in geometric method, which is 54,696. But which is more than the value what we are getting in arithmetic method, 52,500. So incremental increase method will ensure, the value like P1, P2, P3 values on the basis of same data, past data are same, will ensure the values in between arithmetic method and geometric method. Ensure the values in between arithmetic method and geometric method. मतलब अरिथमेटिक मेथड जो वैल्यू देगा अगर वो अंडर एस्टिमेशन है, और जियोमेट्रिक मेथड जो वैल्यू देगा अगर वो ओवर एस्टिमेशन है, उसके बीच वाला कहानी है इंक्रीमेंटल इंक्रीज मेथड. दैट मीन्स you are somehow you are somehow neglecting the underestimation and overestimation both. Is that clear? Okay. So as it is confused growth rate method is there, so eventually no portion of the curve is provided. So once again, if you move back to the curve here, so what is happening? The AB segment, as the DPDT is almost zero, P is constant, there is no population forecasting process is required. For BC segment, there is geometric mean method is there. For CD segment, there is arithmetic mean method is there. For confused growth rate, it is incremental increase method is there. Beyond point D, there is one particular process is there, one particular method is there called as decrease in growth rate method. Now, we are going to discuss about that particular method. The fourth one is decrease in growth rate method. Now, see, for decrease in growth rate method, population after one decade, everything will be discussed. Population after one decade is defined as P1 is equal to P naught plus R naught minus D bar into 100 into P naught. Everything will be discussed. What is R naught, what is D bar, everything. But equals to P naught. If you take common from P naught, it will be P naught into 1 plus R naught minus D bar by 100. So here P1 where P1 is equals to P naught plus R naught minus D bar by 100 into P naught. Okay. So population after 2 decades, similar fashion, P2 is equals to P1 into 1 plus R naught minus 2D bar into 100, as P1 is equals to P naught into 1 plus R naught minus D bar into 100 into 1 plus R naught minus 2D bar into 100. Is that clear? So this is P1, this is the formula, and for P2 this is the formula. So from this fallacy P1 and P2, population after nth decade, what should be the population of the nth decade formula? Pn is equals to P naught into 1 plus R naught minus D bar into 100 into 1 plus R naught minus 2 D bar into 100 dot dot dot, it will be up to 1 plus R naught minus n D bar into 100. Is that clear? If it is P3, only there will be one thing, 1 plus R naught minus 3 D bar into 100, and you need to stop. So eventually that is the formula of Pn for decrease in growth rate method, and it is applicable for beyond point D of the curve. Beyond point D of the curve. So P1 is P naught plus R naught minus D bar by 100 into P naught, or P naught into 1 plus R naught minus D bar by 100. Population after 2 decade, P2 is equal P naught into 1 plus R naught minus D bar by into 100 into 1 plus R naught minus 2 D bar by 100. And population after nth decade will be Pn is equals to P naught plus 1 plus R naught minus d bar by 100 into 1 plus R naught minus 2 d bar by 100 into 1 plus R naught minus n d bar by 100. Okay. Now, written here means that is applicable beyond point D and the Ct is approaching towards saturation. That is important. The Ct is approaching towards saturation. Now here R naught is defined as the percentage increase of the last known decade. R naught is defined as the percentage increase of the last known decade. And D bar is mentioned here, the average decrease in percentage increase. Now, what is that? I will explain. Just note down the term that average decrease in percentage increase, and where R naught is the percentage increase of the last known decade. Well, one thing I should tell that after the completion of one single chapter, I will provide the notes in that description box. We'll get the PDF format of these notes in the description below. Okay. After completion of single chapter, like after today, I'm going to complete the second portion of the chapter. Then in the next class, we will solve all the questions, whatever is there, whatever types is there. We will solve all those questions. Then we'll give. Then I will go for the second chapter. After completion of the problem, again I will give the notes in the description box. Now, so the first thing is here, same problem we are solving. 1930 25,000, 1940 28,000, 1950 34,000, 1960 42,000 and 1970 47,000. तो हमारे पास R वैल्यू का जो है वो R वैल्यू we can find it out. Now, after R values, what we need to go for is D values. Now, try to understand. Till now, estimated for this उस इंक्रीज के बाद y वैल्यू निकाले हैं, दैट इज ऑल्सो x2 माइनस x1. r का वैल्यू जो है वो x1 के ऊपर डिपेंड करता है, r x के ऊपर. तो हम लोग y का वैल्यू निकाले हैं. y का वैल्यू भी ऐसा है कि वी हैव एस्टिमेटेड फॉर x2 माइनस x1 फाइनल माइनस इनिशियल, बिकॉज y ऑल्सो सी y का डेफिनेशन है, अभी आप देख लो, एवरेज ऑफ इंक्रीमेंटल वैल्यूज पर डिकेड इंक्रीज. अभी इधर अभी तक का जो कहानी है that is increase. So if till now we are talking about the increase values, so increase is denoted as final minus initial. Increase is denoted as final minus initial. Okay, so obviously decrease is nothing but minus of increase, negative increase. So that is nothing but initial minus final. Okay. Now here D bar is actually averaging the decrease in percentage increase. So percentage increase is R value. So D is actually initial R1 minus R2. So that's why here D1 is R1 minus R2. Here D2 is R2 minus R3. Sorry, sorry, R2 minus R3, and D3 is R3 minus R4. These are the D values. And what is R naught? What is the R naught value defined? Is the percentage increase of the last known decade. अगर आपके पास last known decade वाला है percentage increase, that is this 11.9 is actually your R naught. R naught is 11.9 mentioned here also R naught, and D bar will be the, this is D1, D2, D3, उसका जो average है that is your D bar. Okay, and they are asking to find out. So after that, you can easily solve for the question, that is what is P1, P2 and P3. Like P1 is will be equals to P naught into 1 plus R naught minus D bar by 100. That's it. P2 is equals to P naught into 1 plus R naught minus D bar by 100. into 1 plus R naught minus 2d bar by 100, and P3 is equals to P naught into R naught minus d bar by 100 into R naught minus 2d bar by 100 into R naught minus 1 plus is there, R naught minus 1 plus R naught minus 3d bar by 100. Okay. So these are the thing we are actually concerned about. Now, there is another part. So there is another part, that is another equation, another process is there, that is called as logistic curve method. Now in logistic curve method is actually this is a again first order autocatalytic equation is used, where ln ps minus pt by pt is equal minus, this is the equation written here. It is I can forget this is a long equation, is the long calculation is required. Forget, you don't have to bother about that equation. Chances of coming questions from this equation is less. But Pt is defined as Ts by 1 plus m into e to the power nt. Ps is equals to this, and m is this. Ps is defined as 2 into P naught into P1 into P2 minus P1 square, P into P naught plus P2 by P naught P2 minus P1 square. M is given, n is given. Where m and n is this, or everything is given. Try to understand. Till now, whatever we have done, is actually we have done in this process. Key, your population is given for a particular decade values, right? Till now, whatever we have done. So here, they will provide three values. What are the three values? That P naught, P1, and P2. Where P naught would be population at time t equals to 0. P1 is population at time t equals to T1, and P2 is population at time t equals to T2. This thing is there. Be careful about the part which is very, very important. The time will be calculated from the initial. This is the thing. Very important. Time will be calculated from the initial. Previously, what we are from where we are calculating the time. We are calculating the time not from the initial. We are calculating the time from the last known decade part. Here time will be calculated from the initial. Okay. अगर P naught, P1, P2 दिया गया है, आपका पहला काम होगा PS निकालना. Then you will go for the calculating M and N, and then you will go for PT. Okay. Clear? That is the thing. That is there we need to go for logistic curve method. Is it okay? Now, apart from these five methods, whatever we have seen, arithmetic mean method, geometric method, incremental increase method, decreasing growth rate method, and logistic curve method. Apart from these five mathematical or statistical inclined methods, there are three methods are there, which is theoretical methods like graphical method, master plan method, and comparison method. I'm just briefly explaining them. For graphical method, what else is there? That for graphical methods, we will go for like there will be two cities. One particular city is there which is having a already is having a plot, and suppose a single city is there, like the plot is happened for a time. Sorry. The plot is there already, and then you are by depending on this slope, you are actually taking average slope and you are extrapolating that particular by this average slope. It's called as the graphical method. It's very good such method, but yes, sometimes it is done where the past data or trend analysis is not at all possible. Second one is master plan method. Master plan method is actually done in design or planned cities. In India, as example, Chandigarh or Gandhinagar, these places are having this design and planned cities master plan method. What will happen? Like a particular area will be divided into certain plots, residential plots, equal residential plots. It's not sellable plots, they are leasable plots. They will provide lease for certain years. So these are the plots provided, and it is assigned that they will give the permission for a building for 3 stories or 4 stories, or properly let it be a single building will be there. So 1, 2, 3, 4, 5, 6, 12 plots are there. 12 buildings will be there, and they will assume that okay, in that building one family will be there. So for this area, 60 is the maximum population they are expecting, and everything will be designed on the basis of this 60 population. It's already defined how much will be there, how the things will run. Okay, that is the master plan method. In comparison method, what will happen? There will be two cities. There will be A and B. So if A is the old city and it is having a particular population forecasting process, and or not population data, old data is there, and that trend analysis can be done. And another city is B, but it is almost climatologically and positionally, it's or the symmetric things are there with A. In that case, what will happen? We will see that okay, as A has followed this particular trend, B will follow that the same trend, as they are climatologically same, or their other things are same as A, is the process. Okay, that is for the comparison method. Okay. What we have discussed today: population forecasting methods. What is population forecasting? It is a method of forecasting the tentative population of future decades on the basis of past population data trend analysis of a particular catchment. And this population forecasting is done it is done on the basis of this, means this is a curve which is, this curve is actually giving you the segment, sequential segment of the projection of population versus time plot. Where saturation, this curve is called as S curve or sigmoid curve or logistic curve. Saturation population is provided here. P is there, T is there. Okay, and that is what is the AB segment, its lag phase. P is constant, dPdT will be equals to 0. Exponential growth phase, dPdt is exponentially there. CD is constant growth rate phase. dPdt is constant. Beyond point D, decrease in growth phase. Okay. BC segment, in BC segment exponential growth will be there, and CD segment they will recheck their growth rate because they will realize all those things are already discussed. Now, the different methods. Arithmetic mean method. This is applicable for old and settled cities. Then it is dPdt will be constant. As the dPdt is constant, it is representing the CD segment of the curve. Equation is defined by Pn is equals to P naught plus Nx bar, where Pn is the population after nth decade. P naught is the population of last known decade, and N is the number of decade. X bar is the average increase in population per decade. X bar is the average increase in population per decade. Okay. And graphically, if you represent, it will be a straight line, the CD segment of the curve, where dPdt will be constant. So for a given dt, dP1 will be almost equals to dP2. We have solved the question problem by which we have seen that what is the process is happening there. From 5 data decades data is given, P1, P2, P3 we have calculated there. We have calculated all those things. We have seen what is x1, what is x2, what is x3. Everything is explained here. After that, there will be geometric increase method, which is suitable for young and rapidly growing cities. What is the BC segment of the population forecasting curve? And here for a given dt, dp1 will be less than dp2 will be less than dp3. एक्सपोनेंशियल ग्रोथ यहाँ पे एज्यूम किया जाता है, तो ऑब्वियसली इट इज फॉलोइंग द दैट इज बीसी सेगमेंट वंस अगेन, एंड मैथमेटिकली डीपीडीटी इज डायरेक्टली प्रोपोर्शनल टू पीटी, एंड डीपीडीटी का सारे चीज यहाँ पे एक्सप्लेन है. तो मैथमेटिकल इक्वेशन जो फॉर्म हो रहा है दैट इज p2 by p1 is equals to e to the power k t2 minus t1. कीप इन माइंड कि जब पर ईयर ग्रोथ रेट दिया जाता है तब यू नीड टू गो फॉर दिस पर ईयर वाला कहानी के mathematical approach. This is where equation is p2 is equals to p1 e to the power k t2 minus pt1. p2 is equals to p1 into e to the power k t2 minus t1. Statistical approach will be where pn is equals to p naught into 1 plus r by 100 whole to the power n. pn is equals to p naught into 1 plus r by 100 whole to the power n, where r is the growth rate percentage per decade, where r is the growth rate percentage per decade, where r is equals to r will be the geometric mean of different r values. And whereas the 1932, once again the same problem is listed here, and in the same problem 1930 to 1970 all the x values is given, r values is given, and r value is estimated here. From that P1, P2 values are estimated P0 into 1 plus R by 100 whole to the power n. And we have seen that if on the basis of same data, if you are going to calculate the population of by arithmetic method or geometric method, you are in arithmetic method you are getting lesser value, in geometric method you are getting quite a higher value, and eventually what you will see that on the basis of same data, past data, quite good difference is there in the population estimated. In incremental increase method, there will be a process in incremental increase method where Pn is equals to P naught plus n x bar plus n into n plus 1 by 2 into I bar. But growth rate is confused, and which will not allow will to get underestimation by arithmetic method, and will not allow to get overestimation by geometric method if confused growth rate is there. After that, again we have solved the same question, same problem will there. Now, decrease in growth rate method, it is the beyond point D of the curve. Population after 1 decade, it is happening. P1, P0, everything is there after 1 decade. And P1 is P0 plus into 1 plus R0 minus D bar by 100. I have shown you that what will be after 2 decade. Then we have gone for what will be after nth decade. Okay. Now, the same question we have solved. We have seen what is D value and what is R naught value, that we have also seen there. Then logistic cut method, when 3 decades, the 3 data are given, and not decades, there that is doesn't have a matter key whether it is decade value or not. And also one thing we need to keep in mind, that time has to be calculated from the very initial. Time has to be calculated from the very initial of this process. Okay. There are some theoretical methods are there, graphical method, master plan method, comparison method, that also we have discussed. Now, so that is the end of chapter 1 completely. So that is the end of chapter 1. In brief, I am just going for the through the whole chapter 1 itself. So first there will be the course overview I have done here. Once again, I am telling you, not in gate noise pollution. Mentioned here just to uh, give you the idea for others examination also, like PSU and all. So in brief, first chapter, what we are entering, first water supply scheme, and to design the water supply scheme, the most important things, the basic things what we require is the discharge or the hydraulic load, which is function of population and per capita water demand. If population increase, Q value will increase. What is per capita water demand? We have seen. We have seen the types of water demand. Then, in briefly, we have discussed all the types of water demand. We have gone for the fire demand part. In fire demand, we have seen the all the empirical equations to find out the water demand for fire extinguishing process. And we have factors affecting per capita total demand, then the variations in water demand, and then we are going for the design period, components of water supply scheme. We have entered today the population forecasting methods. So that is the two segments. First segment, water demand segment, is a theoretical segment. Second segment, population forecasting segment, is the this is the part where we are going for this practical and numerical segment is there. So that is the end of first chapter. In next session, we will go for the problems of this first chapter. We will completely finish the first chapter. Before closing the session, What I should mention once that uh, please keep that in mind that Unacademy is launching the Evolve for Gate 2022, where civil there is the first batch A in both the language English and Hindi, and starts on 28th December 11:15 a.m. with the top educators there. And also, don't forget when you are going for this, don't forget to use my code SEN1010 uh, when you are going for the subscription payment. You'll go get discount. And also, I'm just repeating once that you need to, if you want to install the Unacademy Learning app, go to the Play Store. You will go for this Unacademy Learning app, install it, and go to Gate and ESC and go for Plus. You will get all those things and get subscription. Okay. Uh, so I'm asking for any doubts there. Once again, after completion of these notes, uh, after completion of these notes, uh, all those things will be there. After completion of the whole chapter, I will provide you the notes. And recently, today itself at 6 p.m. Unacademy Combat is there, which is eventually all the largest Fortnite competition. It is, and the prizes, if you will see, first is Apple MacBook Air. All those questions are set by the top educators. Detailed video solution will get. Second prize will be Apple iPad Mini. Apple AirPods is the third prize, and top 100 rankers will get ₹1,000 Amazon vouchers. Go and crack it. Any doubt is there, you can ask it right now, or you can put in the